Have you ever imagined a phone you could roll up like a piece of paper? Or a computer screen that fits perfectly around your wrist? This is the world of flexible electronics. These are amazing new gadgets that can bend, twist, and stretch without breaking. We are already seeing the beginning of this technology, with things like smartwatches that track our health or fitness bands that count our steps. These devices are designed to move with our bodies, making them super comfortable and easy to use. The possibilities are truly exciting, from clothes that can monitor our vitals to medical patches that deliver medicine right through our skin. The one thing all these amazing gadgets need is power, and that's where things get a little tricky. Our current electronics, like our smartphones and laptops, use batteries that are hard and boxy. They are strong and hold a lot of energy, but they can't bend at all. If you tried to bend your phone battery, it would break and could even be dangerous. So, for flexible electronics to really take off, we need a brand new kind of power source. We need batteries that are just as flexible as the devices they are powering. This is a huge challenge for scientists and engineers. Imagine a t-shirt that can check your heart rate while you exercise, or a bandage that can tell a doctor if a wound is healing properly. These fantastic ideas need a battery that can be woven into the fabric or stretched over your skin. A normal, rigid battery just won't work. It would be bulky, uncomfortable, and would break as soon as you moved. The solution is the flexible battery, a power source designed to be bent, folded, and even stretched, all while safely providing the energy our devices need to function. It's a key piece of the puzzle for creating the next generation of technology. So the big question is, how do we make a battery that can do all of that? We need to completely rethink how batteries are made. Instead of putting all the battery parts into a hard metal case, we need to use new materials and new designs that allow for movement. The goal is to create a power source that feels less like a brick and more like a piece of fabric or a rubber band. This would unlock a whole new universe of electronic devices that can integrate seamlessly into our lives, our clothes, and even our bodies, making technology feel more natural and helpful than ever before. To understand why making a flexible battery is so hard, let's first look at how a regular battery works. Think of a battery like a little sandwich. It has three main parts. The first layer is the anode, which is the negative side. The second layer is the cathode, which is the positive side. In between them is a very important layer called the separator, which keeps the anode and cathode from touching. Finally, all of these parts are soaked in a liquid called an electrolyte, which helps electricity flow. When you use a battery, tiny charged particles called ions travel from the anode, through the electrolyte and separator, to the cathode. This movement creates the electrical energy that powers your device. The problem is that all these parts are usually made from stiff, brittle materials. The anode and cathode are often made of metal foils coated with powders, and the separator is a thin sheet of plastic. These materials are great for storing a lot of energy, but they crack and fall apart if you try to bend them. The metal casing that holds everything together is also completely rigid. It's designed to protect the delicate chemistry inside, not to be flexible. Bending a traditional battery would cause the layers to break, the electrolyte to leak, and the battery to stop working completely. Making a battery flexible means we have to change everything about its design. Scientists are experimenting with new materials that can stretch and bend without breaking. For instance, instead of using stiff metal foils, they might use materials like carbon nanotubes or graphene, which are incredibly strong and flexible. They are also developing new kinds of electrolytes that are not liquid, but are more like a solid gel. These solid-state electrolytes are much safer because they can't leak, and they can be made to be bendy, like a piece of soft plastic. The challenge doesn't stop there. All the parts of the battery must stay in perfect contact with each other, even when the battery is being twisted or stretched. If the layers separate, the flow of electricity will stop and the device will turn off. It's like trying to make a sandwich that you can fold in half without any of the fillings falling out. Engineers have to figure out how to stick all the flexible layers together in a way that is strong, but also allows for movement. This requires incredible precision and brand new manufacturing techniques to get it just right. To solve the flexibility problem, scientists are throwing out the old boxy battery design and creating some amazing new shapes. One popular approach is the thin film battery. These batteries are built layer by layer on top of a flexible surface, like a thin piece of plastic. Each layer is incredibly thin, sometimes thinner than a human hair. Because the whole thing is so thin, it can be easily bent or rolled up without damaging the internal parts. This method is great for making batteries that are flat and can be integrated into things like smart cards or flexible displays. Another super cool idea is the fiber-shaped battery. Imagine a battery that looks and feels like a single thread of yarn. Scientists create these by building the battery components, the anode, cathode, and separator, in long, thin strands. These power-producing fibers can then be woven or knitted directly into fabrics. This means your future jacket could have a battery woven right into it, powering sensors or even small lights without you ever noticing it's there. These fiber batteries are incredibly flexible and can withstand being stretched and washed just like regular clothing. Manufacturing these new batteries also requires new methods. Traditional battery factories are not set up to make bendable power sources. One of the most exciting new techniques is three-dimensional printing. With three-dimensional printing, scientists can create batteries in almost any shape they can imagine. They can print a battery that fits perfectly into the curved frame of a pair of smart glasses, or one that matches the exact shape of a medical implant. This allows for custom-made batteries that are designed specifically for the device they will power, making everything more efficient and compact. Of course, there is a big trade-off to consider. Often the more flexible a battery is, the less energy it can store. A super thin, bendy battery might not be able to power a device for as long as a thick, rigid one. This is known as the balance between flexibility and energy density. Scientists are working hard to improve this. They are searching for new materials that are both highly flexible and can hold a lot of charge. The goal is to get the best of both worlds, a battery that can bend and stretch while still providing enough power to keep our gadgets running all day long. As we design batteries that can be worn on our bodies, safety becomes more important than ever. A battery in your shirt or on your skin has to be completely safe. It can't overheat, and it definitely can't leak any harmful chemicals, especially when it's being bent, stretched, or even put in the washing machine. This is why many researchers are focused on solid-state electrolytes. Since they use a solid gel instead of a liquid, there is nothing to leak out, which makes them much safer for wearable devices. These batteries also need to be durable, able to withstand thousands of bends and twists without losing their ability to hold a charge. The toughness of these batteries is key to their success. Think about a fitness tracker you wear every day. It gets bumped, it gets sweaty, and it moves with you constantly. A flexible battery powering that device must be able to handle all of that wear and tear and keep working perfectly. Engineers perform stress tests where they bend, stretch, and twist battery prototypes thousands of times to see how they hold up. They are developing self-healing materials that can automatically repair tiny cracks that might form over time, making the batteries last even longer and perform more reliably. With safe, durable, and powerful flexible batteries, the future of technology looks incredible. We could see electronic skin, or e-skin, that gives robotic hands a sense of touch or helps burn victims regain sensation. Imagine medical implants that monitor your body from the inside and are powered by a battery that moves with your internal organs. We could have newspapers that update with live video, or wallpaper that doubles as a giant television screen. All of these ideas, which sound like science fiction today, become possible when our power sources can finally break free from their rigid boxes. Ultimately, flexible batteries will allow technology to blend more naturally into our environment and our lives. Instead of carrying around hard, separate devices, technology will be integrated into the things we use and wear every day. Our clothes, our accessories, and even our bodies could become smarter and more connected. The development of flexible batteries is not just about making our existing gadgets bendy. It's about inventing entirely new categories of devices that will help us in ways we are only just beginning to imagine. The future isn't just bright, it's flexible.